Okay, guys, so we are talking about relations and functions, and I think up until now, whenever we've said functions, we've kind of just said, oh, functions are graphs. All right, but the opposite is not always true, not? So all functions can be drawn as graphs, but not all graphs are actually functions. All right, sometimes a graph just represents a relation. So that's what they're saying here, the definition of a relation. And again, guys, I'm not going to ask you to write down the definition in a test or exam, but you do need to be able to apply it. So they're saying a relation is a rule that associates elements of one set of numbers with elements of another set. So that sounds very complicated, but it's just basically saying that a relation is almost like the relationship between input and output. Does that make sense? So here they have a diagram where they're saying, sorry, here the relation is squared. So 1 when you square it, you get 1. 2 when you square it, you get 4. 3 when you square it, you get 9. Right? So it's an input value. There's some kind of process happening, which usually we call the function, all right? But sometimes we just call it a relation. I'll explain the difference just now. And then we have output value. So here they are actually saying that the components of a relation. So you can just highlight that. A relation can be thought of having three components. So we have the input set. So guys, we actually talk about the domain, all right? Remember the domain? Those are all the x values. Okay, the x values are always the input values. If you think of a straight line equation, y equals 2x plus 1, right? We sub in x values and that will give us y values. So the x values are always the input values, the domain, and the range, the y values, always give us the output value. So the output set, that's the range. So if you want, you can just put an x above domain and a y below range. Oh my, that is what we're talking about. And then we have a rule. Okay, so if it is y equals 2x plus 1, the rule is you multiply the input value by 2 and then you add 1. Okay, and that's what you did in grade 8 and 9. You have to learn how to translate, that kind of description into an actual formula, into a rule, into an equation. Okay, it's all kind of tied together. Now then they're just showing here other ways of representing a relation, doesn't matter. You have a table, so they're saying if you have natural numbers and then multiple with 3, the rule would be multiplied by 3. You don't really need to know this, it's just showing you kind of tying different areas of work that we've done before together. Then you can have a formula, for example, here x equals 4,9 times t squared, or like I just said, y equals 2x plus 1, all right, that's a formula. And then a graph as well, okay, like we just said for a straight line, that is a graph. It's a way of showing, graphically representing the relationship between an input and an output value. Okay. Let me just see here. Okay, so now, these are things that you do need to know. You need to know what these different types of relations are called. So you can just highlight that, relations between input and output variables. Okay, so guys, here, when you have a one-to-one relation or relationship, now that is what they've tried to show here in this diagram, where every input, every x value only has one y value that's associated with it, right? So that's what they're trying to show here. If your x value is a, then it only has one y value that's associated with it. So if you're thinking of y equals 2x plus 1, right? If you sub in x equals 0, you're only going to get one y value from that. Does that make sense? Right, so 1-to-1 is saying every input is mapped to one unique output. Each x value has only one y value. You can add that there. Each x value has only one y value. So then I have some examples there. They're saying linear, so like straight lines. Hyperbolic, that's hyperbolous, obviously, right? And exponential relations are all one-to-one. Okay, because if you sub in one x value into that equation, you will only get one y value as an output. Okay, so that's one-to-one. The next one is many-to-one. Now that means that multiple different x values could possibly give you the same y value. Now guys, can we quickly visualize a parabola? Right, say it's just a parabola with a turning point at the origin, right? So there's a turning point at the origin and it's going up. It's going to have the same y value on either side of the turning point. Do you remember that? Right, so if you have your parabola, let's see, here's an example on the next page. Okay, here's a parabola, there is the turning point. Here we have an x value of -1 and a y value of 1. But here we have an x value of +1 and the same y value. So multiple x values give us the same y value. All right, does that make sense? That is what happens with the parabola. So a parabola is called a many-to-one relation because multiple x values, here they're showing two different x values, give you the same y value as an answer. Okay, so every input is mapped to one output. No, that's not correct. Let's change that. We'll line through that. It only requires any two inputs to have the same output to be many-to-one. Let's highlight that. Okay, so I'm just going to write in terms of x and y. No, sorry. Let's say multiple x values can give the same y value. Okay, now these are obviously set up using, proper names in the same quadratics, but just in case you're not sure what that is parabolas. So you can add in at the top, and you're saying that quadratics are many-to-one relationships. You can just add the parabolas. Parabolas are quadratic graphs, right? Because it only has an x-way. Okay, then the next one-to-many, and we haven't actually seen graphs where this happens, right? But if you're looking at this diagram here, you can see that an x value of a is giving two different y values, right? One-to-many. Are you seeing how the naming works? When it's one-to-one, it means one x value to one y value. When it's many-to-one, it means many x values, one y value. When it's one-to-many, they say one x value can give you many y values, multiple y values. Okay, now I want you to look at this diagram on the second half of the page. This is a parabola that's lying on its side, basically, which we haven't done yet. Okay, that's something new this year. We actually call this the inverse of a parabola, which is a big section that we add into functions this year. But this is what they're talking about, guys. So if we have an x value of 1 here, all right, or even let's look at the x value of 0, you see that that x value has two y values associated to it, right? So at the point, or at the x value of 0, we have y is what's that, 1, 3 or whatever, and -1, 2. Okay, so this is an example of a one-to-many relation. Okay, one x value, multiple y values. So we can highlight that there. At least one input is mapped to more than one output. All right, so we can add one x value has more than one y value. And then they're saying there at the bottom, a parabola on its side is going to start with. And then many to many, you have seen one type of graph that looks like that. And many to many is obviously where multiple x values can have multiple y values. Yes? So they're saying that, but no two inputs have the same output. So that's not really that important, but that is just saying this kind of thing. So they're saying that a one to many is not a many to one. Because a many to one can have two inputs having the same output. So now they're saying at a one to many, that doesn't happen. Okay, so they're just showing the difference between the two labels. So guys, a many to many, they're saying that inputs have multiple outputs and vice versa. That's a bit difficult to explain, but if we're thinking of a circle, you guys remember last year when you did analytical circle geometry, right? The circle that was drawn on the Cartesian plane after Euclidean ones, where you did all those theorems. You remember where you had a Cartesian plane and you had a circle with the center, say at the origin, and went all around. Okay, so those types of graphs, let me see if I can show you the graph from the book. Guys, by the way, while I'm on this topic, the circle chapter that we copied for you guys last year is in this textbook. It was actually, remember, it was actually the trick word. 249. So let me just get to one actual value. Right, if we're looking at that. Right, we're doing here, let's see. Okay, so they're saying multiple inputs have multiple outputs. So what did they say? What's the wording there? Inputs have multiple outputs and vice versa. So if we're looking at -4 as an input value, no, let's not do that. Let's look at, okay, 0 as an input value, all right? It has 2 y values. Do we see that? All right? But then we can also say that a y value of 2, a y value of, which one can I choose now? A y value of, let's say that's -2 there. Do we see that this y value also has multiple? No, it must be on the graph. Sorry, my brain is a bit foggy. A y value of -2, let me show it there. Here we go. Do we agree that those 2 points will have the same y value? It's supposed to be in a line, so in the case it's not yes. Okay, there we go. So those 2 points have different x values with the same y value. Okay, so what did we say this is? This is probably -3, -2, and this is 3, -2. Okay, so what I'm trying to say is we have the same y value, multiple x values, but then we can also have the same x value, 0, multiple y values. Okay, does that make sense? So we can have the same x value giving us multiple y values, but we can also have the same y value that has multiple x values. Okay, so it's basically many to many is a combination of the previous 2. Okay, so I'm just going to write that down. So the same x value has multiple y values. And the same y value has multiple x values. And they're saying there, like, for example, a circle. Okay, so there's a lot of information, guys, and it might seem like a lot to remember, but the way that they ask these questions, I'm going to show you a line test that you can use. It's on the next half of the page. A line test that you can use in order to, if they're asking you, is this a one-to-one or many-to-one or one-to-many or whatever, then you use the line test and you get your answer. Okay, so we're not going to ask you to define any of these 4 marks. All right, you just need to be able to basically identify them. Now, very important here, it's too bad that it's right at the bottom of the page because this is basically the crux of this whole first part of this chapter is what a function actually is. So this whole time we've been speaking about relations and we've been speaking about graphs, but we haven't actually decided or spoken about what a function is. So a function is a relation where each input only has one or has only one output. And that is a definition that you do need to be able to write down. Because sometimes in a textbook exam, they'll give you a graph and they'll say, is this a function? Explain why, and then you have to say yes, because each x value has only one y value. Or yes, because each input has only one output, or no, because there is an x value that has multiple y values associated with it. Okay, so they're saying further down, a function is either one-to-one or many-to-one. Because what's important for something to be a function, each x value has to have only one y value. Okay, but you can have multiple y values having the same x value. Okay, so it's important, guys, that you just have that there, that one-to-one and many-to-one, those are functions. So let's go back up higher to the actual many-to-one and one-to-one on the previous page. Many-to-one, this or these are functions. Okay, so just write there, functions. So for example, a parabola is a function. Okay, parabola is many-to-one, it is a function. And then if you go to the previous page where we had one-to-one, that definition, one-to-one relations are also functions. So it's the 2-1 part that makes it a function. Okay, either one-to-one or many-to-one, but it has to be 2-1 y value. That makes it a function. If it's too many, then it's not a function. Okay, it's going to take some time to get used to that. But yeah, that's basically what it comes down to. Yes. Yeah, so we are going to talk about it a bit more, but it's not really that big a thing. Yes. Yeah, but if they ask you a question like that, you're either going to have to do the line test, which we're going to talk about now, or you can just look at it and see, oh, it's a parabola, it is a function, and just say, yes, each x value has one y value. Doesn't really go much further into that. All right, guys. Here they're also saying a one-to-many relation and a many-to-many relationship. Relation as well. Are not functions because they both have one input associating with more than one output. Okay, you can highlight that if you want. Just showing, but it's just that thing of if you just remember, if it's a 2-1, then it's a function. All right, the 2-1 that has to do with the y value. So as long as it's like anything 2-1 y value. Oh. All right, guys, let's go to the actual line test because that is going to make things a bit easier. Again, it's very wordy. I'm going to try and summarize it because it's not actually as complicated as it seems over here. All right, so they are saying we basically use the vertical and horizontal line test for 2 different things. So firstly, if we are just highlighting the vertical line test, now that can be used to decide whether a graph is a function. And now you do obviously have to have a graph in order to use the line test because you're literally going to draw a line on the graph. So there we can just highlight the bottom or the next sentence there. If a vertical line cuts a graph in more than one place, then the graph does not represent a function. Now guys, if we're thinking of the y-axis, do we agree that the y-axis is a vertical line, right? And what did we just say? A graph is not a function if one x value has multiple y values. So we do this kind of thing. You can actually just take your ruler. You don't physically have to draw a line onto the graph. But I'll just show you. If we're looking at this one here at the bottom, right? The ruler actually represents an x value, okay? Because we're moving it across the x-axis. And if this ruler cuts the graph twice, that means that for one x value, we have two y values. Right? Does that make sense? So for the vertical line test, we use that to decide whether something is a function or not. So we move it, obviously vertical, so it has to be vertical, right? Your ruler has to be vertical. So the ruler represents an x value, and then if the ruler at any point, guys, if it cuts your graph more than once, that means that you have more than one y value. Okay, so you can just remember that the vertical line test is like your y-axis. So we use it to check if there are multiple y's. Okay, which is going to tell us whether we have a function or not. So let's see, what did they write here? They've actually listed like a whole method. Run a ruler parallel to the y-axis, i.e. vertical. Move it from left to right over the graph. If the ruler only ever crosses the graph at one place as it moves across, then the graph is a function. If the ruler at any stage crosses the graph at more than one place as it moves across, then the graph is not a function. This is because a single x value will be associated with one y value. Okay, so I don't really want to highlight all of that because all of it kind of seems equally important. I think I'm just going to highlight the bottom bit, all right? Because that kind of implies everything else. But you can obviously highlight more stuff if you want. So I don't need that. Okay, so if they've given you the actual graph and they're asking you whether it's a function, then you can use that line. Okay, obviously if there's no graph drawn, then you can't move your ruler over the graph. Okay, we'll talk about that later, what we then actually would have to do. Okay, so then once you have decided whether it's a function or not, you can then use the horizontal line test to check whether it's one-to-one or many-to-one. Okay, so let's highlight that. Whether the function is one-to-one or many-to-one. So guys, they don't ever ask is it one-to-many or many-to-many. They always only ask about one-to-one or many-to-one. Okay, so the horizontal line test checks for that. So what you're going to do, just like we did now with the vertical line test, you're going to run it if you're looking at this one. So this is not a function, right? Do we all agree? We're doing the vertical line test. We check, oh, the ruler cuts it twice. That means that this is not a function. Okay, this one would be a function because as we are moving the ruler and we're going from left to right, do we see that the ruler only ever cuts the graph once? All right, so this is a function. So now we can turn our ruler so that it's lying horizontally. And now, if we are moving the ruler from the top down, from the top down, then do we see that this ruler is now cutting the graph more than once? That means that this is a many-to-one. Okay, if it cuts it more than once, it's a many-to-one. If it cuts it only once, so if we're thinking of a straight line, for example, right? Can we visualize that? If you have a straight line and you're moving your ruler down, it will cut it only once. That's a one-to-one function. Okay. So let's just highlight that. Crosses the graph at one place, then it's a one-to-one function. And if it crosses the graph at more than one place, then it is a many-to-one function. Now this is important, guys. The horizontal line test does not apply if it's not a function. Okay, so let's just highlight that as well. So guys, if you have found something like if we're looking at this graph, right? And they're asking us what type of relation is it? Is it one-to-one, many-to-one, one-to-many or many-to-many? All right. First, you need to check, is it a function? Are we all in agreement that this is not a function? Okay, then we can't use the horizontal line test to decide what type of relation this is. Then you need to fall back on these definitions. I haven't really seen them asking questions like that, but you never know. So then you need to ask yourself, Is it a one-to-many or many to many? All right, so one-to-many is one x value has multiple y values. All right, but if it's many-to-many, that means that one y value also has to have multiple x values. Okay, so we will have to check whether that also happens. Now, if we're just looking at that y value, for example, we'll say that is a y value of 2. How many x values does y equals 2 have? Just one, okay? So that means that this is a one-to-many. One-to-many, yes. Okay, but if it's a circle, and you can just remember those types as well, because if it's a parabola on its side, it's one-to-many, and if it's a circle, it's many-to-many. Those are the only ones that can actually come up. Okay. All right, guys, I would like you to do this work. Quickly going to check what exactly they're asking. I'm going to just give this to you blindly. Page 43. Okay, yes, guys, I would like you to do these questions, please. You can definitely finish it in the time that is still left. It's not that much.